Welcome to the very first video of Math with Miss Johnson. Today we're going to look at how to use a factor tree. For today we have two goals. Our first goal is that you will be able to use factor trees to find all the prime factors of a number. The second goal is that you will be able to write the prime factorization for a number. Before we go to actually accomplishing those goals, let's look at some vocabulary that's going to help us. The first one is a term that you're probably familiar with. That's the word factor. Just to review, a factor is each of two or more numbers in a product. So here in this example problem, our product is 21 right here. And the factors that got us there was 3 and 7. 3 times 7 equals 21. Another product might be 18. So two factors that might get us there are 9 and 2. 9 times 2 equals 18. So 9 and 2 are factors of 18. Another vocabulary word that we need to understand is what a prime number is. A prime number is a number that's only divisible by 1 and the number itself. Another way that you could say this is that it only has two factors. So I've listed the first 5 prime numbers as examples. The first 5 prime numbers are 2, 3, 5, 7, and 11. We're going to be using those factors quite a bit, those prime numbers quite a bit. So for example, if we look at the number 5, the only way that we can get to 5 with multiplication is 5 times 1 or 1 times 5. We also can't divide 5 by anything except for 1 or 5. Let's look at 11. For 11, we can't divide 11 by anything except for 1 or 11 and still get a whole number. We also can't multiply anything except for 1 times 11 or 11 times 1 to get to our product. So the only factors are the number 1 and the number itself, both of these cases. So let's look at how to actually make a factor tree. So when you make a factor tree, start with the number, the product. So the problem will usually say, write the prime factorization for the number 18. So here's our example number, 18. So 18, I'm going to use the factors 2 and 9. 2 times 9 equals 18. Now 2, I can't break it down anymore. It's a prime number, so I'm going to stop there. But 3, I can break that down. I can break it down into 3 times 3. So here I have my prime number 2, I have my prime number 3, got to stop there, and another prime number 3, got to stop there. Here's where I'm going to write out my factor string. This is what it looks like. 2 times 3 times 3. Just these numbers that we ended with, 2, 3, and 3. So let's look. Let's check and make sure this gets to 18. 2 times 3 equals 6. 6 times 3 equals 18. So I know that that is the prime factorization for 18. Let's see if we can get that prime factorization by starting with different factors, because 18 has different factors than just 2 and 9. So let's try it again. Let's look at 18. Let's look at 6 times 3. 6 times 3 will get us to 18 as well. So 6 is not a prime number because I can get to 6 by using other factors besides just 1 and 6. I'm going to use 2 and 3. 3, this 3 up here, is a prime number, so I know I have to stop. So I'm going to write my prime factorization. 2 is a prime number, 3 is a prime number. My 3 up here is a prime number, so I can write my prime factorization. 2 times 3 times 3 equals 18. One key is that you always want to write your prime factorization from smallest to greatest. So even if you put the 6 on this side and the 3 on this side, and your numbers were jumbled up, you can switch them and do 2 times 3 times 3, so smallest to greatest. Let's try another one. Let's practice writing out the prime factorization for 30. So we're going to start with 30. And I'm going to use these factors. I'm going to use 3 and 10. Now 3 can't be broken down. It's a prime number, so I'm going to stop there. But 10 can be broken down. I'm going to use 2 and 5. 2 times 5 is 10. 3 is a prime number, so I have to stop. 2 is a prime number. Can I break down 5 any further? No, it's also a prime number. So here I have 3, 2, and 5. And now I want to write my factors from smallest to greatest. So I'm going to do 2 times 3 times 5. Let's see if that makes 30. So 2 times 3 is 6. 6 times 5 is 30. So I'm correct. I can do this another way by using different factors as well. So this time I'll do 2 times 15. See if I get a similar prime factorization. 2 is a prime number, so I'm going to stop there. 15 is not a prime number, because I can get there more than just 1 times 15 or 15 times 1. I'm going to use 3 times 5. So 3 can't be broken down, neither can 5. They're both prime numbers. So now I have 2, 3, and 5. Write them down in my factor string. 2 times 3 times 5. It's exactly the same as the one before. Equals 30. So you know that there's two different ways to get this prime factorization. You don't have to start with only one set of factors. You can use different ones and still get the same prime factorization. As always, you should check your work. So let's try a practice problem before you stop the video. So here I'm going to have you figure out what the prime factorization for 24 would be. So go ahead and pause the video, grab some scratch paper, and see if you can figure out the prime factorization of 24. We'll come back and check it together. So go ahead and pause the video. Great, so you should have this all worked out right now in front of you. One way that you might have done it is to use the factors for 24. You can use 6 times 4. Now 6 and 4, neither of those are prime numbers, so I have to break both of them down. So 6 I'm going to break down into 3 times 2. 4 I'm going to break down into 2 times 2. These are all prime numbers, 3, 2, 2, and 2. And I'm going to write them from smallest to greatest. 2 times 2 times 2 times 3. Let's see if we get to 24. 2 times 2 is 4, times 2 is 8. 8 times 3 equals 24. So I know that that's correct. Maybe you did this a different way. Maybe you did 24 and you used the factors 2 times 12. Let's see if we get the same prime factorization. 2 we can't break down because it's a prime number. 12 we can break down. I'm going to use 2 and 6. 2 we can't break down any further. We're going to stop there. 6 we can. It's not a prime number. So I'm going to use 2 times 3. 2 times 3 is 6. Now I have to stop because I have all prime numbers on the end. So I'm going to use this number at the end, 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 write them out. 2 times 2 times 2 times 3. It's exactly the same as our first example. Equals 24. So go ahead and check your work if you need to. If you need to go back and review, go ahead. Thanks for watching.